work that I've been involved in and the thinking that I've been involved in over the past few years really does suggest that in an ocean with a limited amount of resources and a lot of fish in it, there can be winners and losers. And so to kind of give you the take-home message, there are too many salmon in the ocean depending on what species you are that we're talking about. Now before I jump too far ahead, I will say that I'm a relatively recent graduate from Salmon University, where I spent about 5 years doing my PhD. My PhD work primarily focused on farm fish, wild fish interactions, particularly mediated by sea lice, something for an archipelago. I'm sure many of you guys are familiar with the kind of general body of work. Some of that's going to factor in here tonight. And then I spent a couple of years working on more kind of ocean basin scale interactions between salmon, and thinking about what happens here at home in our coastal marine environment and what that means for fish as they interact at broader and broader spatial scale. I'm a quantitative conservation biologist by nature. That kind of means that I spend quite a bit of time in the field, increasingly less now with small kids and more responsibilities. I'm also really comfortable sitting in front of a computer with numbers. And it's combining an understanding of kind of ecology and what makes the world work from an ecological perspective with trying to rigorously think through quantifying relationships that gets me kind of the most excited and getting out of bed in the morning. So these are a whole bunch of pink salmon here, as you can probably recognize, spawning, and they're going to play a really important role in this talk tonight. I really encourage you guys, it's not going to be a particularly long talk, it's not going to be particularly complex. I really encourage you guys to stop me in my tracks if I'm talking too quickly. If you think something I say doesn't make sense, if you want to call bullshit, please interrupt me and ask questions. It's meant to be a bit more of an interactive occasion than me just talking over and over again. So, are there too many salmon in the ocean? Well, in order to ask that question, we really have to have kind of an understanding of how many fish are out there in the first place. This is a bit of a dated slide now. It only goes up to the mid-2000s. But as you can see, if we look at pink, chum, and sockeye on aggregate across the entire North Pacific, we have more fish, and this has just continued to go up and up now than we did in the ocean at any time over the past 50-odd years. This doesn't say anything about what was going on prior to that, and we can talk a little bit about that later on. But at least over the past half century or more, we're at record abundance in terms of our contemporary thinking around trying to quantify how many fish are out there. Now that may run counter to kind of some of our feelings about how many fish are out here in this part of the North Pacific. When it comes to pink salmon returning to Fraser, I'm sure many of us can appreciate that there's been quite a few pinks returning in recent years, at least in odd years, and we're expecting a pretty decent return of pink salmon this year. And so what's really motivated our thinking about this is what does it mean as you increase the number of fish at a broad kind of ocean basin scale for how many kind of resources and food are out there. And really, in order to get to that question, I have to kind of back up and use both of these kind of cartoons to ground some of the underlying thinking, which at first won't make a whole lot of sense of being part of this presentation, but they really speak to some of my experience and shape some of the underlying kind of themes to this story. So the first one are sea lice. I've already alluded to them. Here in this race-eye cartoon, they're equated to the downfall of Campbell's government and the HST parasitizing the public in BC. Right? There's been a long history of studying sea lice on our coast. I'll be talking a bit about that in a minute. And then in more recent years, there was the Cohen Commission. I'm sure everybody here is familiar with the Cohen Commission and some of the outcomes from it. A lot of the investment in resources and time in trying to get to the bottom and better understanding what's driving the variability and ups and downs of Fraser River sockeye salmon. And where I come in here is really kind of linking thinking around not just sea lice, but aquaculture in general. And what makes salmon populations go up and down, and in particular thinking about both disease risk, both from a salmon aquaculture perspective and a non-aquaculture perspective, competition, particularly at this scale, and sockeye salmon in particular. And so it's a little hard to see that one, but this is a chum salmon, just entered the marine environment, hasn't been there for more than a month or so. These are the fish that originally have kind of let me cut my teeth as an ecologist studying fish. The way the story works, many of you guys I'm sure are familiar with this, is that when we place open net pen salmon farms along really marine migration routes of juvenile fish, we essentially short circuit an otherwise natural system that's created a barrier for sea lice to be transmitted from returning adults to out-migrating juveniles. So you end up with farm fish getting infected by sea lice. They can amplify them. These are sea lice that come from wild fish. Those can spill over into out-migrating juvenile fish as they go out to sea, and that can, in certain contexts, reduce their survival, alter their behavior, and it can have, real, tangible, directly quantifiable population-level consequences for particularly pink salmon, which have been well studied, at least in one region of our coast. And my work really focused. Sorry, that's really tough to see. Why don't we kill the lights up front? That might help a little bit. Where I came along was really being interested in this story from the perspective of this interaction up here. This is still pretty hard to see, but you can see the silhouette. Thanks very much. This is a cutthroat trout that's feeding on a pink salmon early in marine life. When pink and chum first enter the marine environment, as anybody can attest who's used a little juvenile fly pattern fishing for sea run cutthroat trout in the marine environment, that as pinks and chums enter the ocean, they're met with a kind of voracious set of predators, including other salmonids like cutthroat trout and coho, that aggressively feed upon them and gorge themselves on pinks and chums for the first few months of marine life. But after that, the name of the game is pinks and chums grow as quickly as they can. They essentially escape this predation window at the hands of coho in particular, and they move on to being eaten by other species. What I was really interested in, is what the consequences were of unnaturally adding sea lice to this otherwise natural predator-prey dynamic. What ends up happening in this context. And what we ended up showing is that as you add sea lice here, you make pink salmon in particular much more vulnerable to being eaten. That's not particularly surprising. You stick a whole bunch of parasites on your side, you're more likely to fall at the back of the school, not be able to get away as quickly as a predator comes up from behind. What was really interesting is that the sea lice on those pink salmon were really adept at jumping onto the coho. And so as a result of adding parasites to this mix, you end up with this accumulation of parasites on the predators. And it's kind of this self-fulfilling prophecy, right? The easier it is to catch the pinks, the more parasites you get on yourself. And so it turns out that in this case, in this part of our coast, the Brown Archipelago here, coho salmon populations are also depressed concurrent with the depressed pink salmon population. And so we spent a number of years working on this story, testing hypotheses, evaluating. And what we can really say now is that, indeed, if you add sea lice to this picture, it can depress pink salmon and coho salmon populations. And as you tone down and reduce the number of sea lice on farm fish, and slowly whittle away at the amount of lice that are transmitted to wild fish, you can actually turn back off that population suppression. And so you can end up essentially taking care of a lot of the population level negative consequences by managing how many sea lice are on salmon farms. Now, that's kind of where we sit today in that region. It's been a long time getting there in terms of thinking about managing lice on farms. It's still not perfect, but it was inadvertently an incredibly powerful test of the consequences of lice being transmitted from farm fish to wild fish. Because if you can turn them on and off, then you can effectively, really help fine-tune and understand what is and isn't driving variability in pink and coho salmon populations. The story is a little more complicated with chum salmon, and because the focus of tonight is not sea lice per se, I'm not going to go any further than that, except to highlight that for many years, the bulk of our work really focused on this one region right here. And so between a handful of graduate students, folks like Alex Morton and others, we really shed a lot of light on understanding how open net pen salmon aquaculture can alter otherwise natural disease dynamics. Now, while we invested a lot of research and effort here off the northeast corner of Vancouver Island, the industry was still continuing to grow and expand on the coast. This is most of the tenures in the province. If you guys know this stuff well, you'll notice there's a few that are missing on the central coast, but this covers the bulk of them. About 60% of the farm fish that we produce are on the inside of Vancouver Island here. And it wasn't until the late 2000s that it was really driven home, based on the work that's going on here and some precipitous declines within the Fraser itself, that people really started raising concerns around the potential for salmon aquaculture to be contributing to what's going on with Fraser sockeye. Couple that with the appearance of those sockeye populations that are to the north and to the south that don't migrate past a lot of salmon farms, that appear to be doing better than those that migrate up the inside of Vancouver Island. And that really raised a lot of red flags for folks. And combined with many other factors, kind of led to the Honorable Stephen Harper taking the available steps that were there for him in the fall of 2009. I'm sure Finn can talk a lot about the politics behind calling this inquiry. But essentially, the government was tasked with taking all feasible steps, right, to identify the reasons for the decline of Fraser sockeye in the Fraser River. And so started a multi-year, $20 million+ process that helped pay for many mortgages, many people going through school, to try and get a better handle on what's going on in the Fraser River. And at the time, there were many, many, many ideas that were thrown out there. So we've just been talking about aquaculture and pathogens. This was one that was high, particularly on the public's list, but everything from marine mammals, there being too many seals out there and they're consuming all the fish, overescaping or allowing too many fish onto the spawning grounds, climate change, right, the ubiquitous specter of a changing ocean environment, what that might mean for fish, other ocean conditions, toxic algal blooms, competition in the open ocean with other salmon, illegal fishing, volcanic eruptions in the North Pacific, which may change the balance of what's going on in the marine environment, sewage, degradation of freshwater habitat, and the list went on and on and on. Everybody had their own hypothesis, and I'm sure if we had sat in this room, we probably could have come up with twice as many hypotheses as there were people in the room at the time. And so what people were tasked with was working through these many hypotheses and trying to get a general sense of which ones were more likely than others. And then with that reduced set of hypotheses, really kind of trying to rigorously evaluate whether or not there was evidence for and against them. And so from this list, I'm oversimplifying it a little bit, but 4 really key ideas that emerged from this had to do with climate, disease in aquaculture, overspawning or allowing too many fish on the spawning grounds, what that might mean for subsequent generations, and competition. And so this is kind of really the bulk of the story that I want to spend telling over the next 10-15 minutes. It really has to do with thinking through the potential consequences of multiple interacting factors that occur at different scales and what they might mean for influencing the dynamics of a complex of fish like Fraser River sockeye salmon or sockeye salmon more broadly. So from a climatic perspective, people have long known, this is a picture of the Pacific Decadal Oscillation. You can have a system where you have periods of warmer and cooler water, which may change over the course of a couple of decades, that are reasonably correlated with how well salmon do across their range. In years of one phase of the PDO, fish in the southern part of the range, including British Columbia and further south, do better than those to the north, like northern BC, Alaska, and particularly western Alaska, Bristol Bay. And in the other phase, it's the opposite. We also know that early in life for sockeye salmon, the cooler it is for those in the southern part of their range, the better off they do. You end up essentially entering a richer environment that has more food for juvenile sockeye, and that has real tangible benefits in terms of their survival when they come back. And so because climate has been changing, and if you looked at a graph of the change in kind of temperature during early marine life, if you kind of squinted, you could see that it has gone up through time. And so that was identified as a possible driver of what's been going on for Fraser sockeye. Disease in aquaculture, we've already kind of touched upon a little bit, right? The idea was here that we know that in some circumstances, for some species, aquaculture can be an important contributing factor to the dynamics of wild fish. And we know that Fraser sockeye have to migrate through very narrow inlets and fjords past many, many farm fish. And so the potential for there to be interactions of a diseased nature and a pathogen nature between the two were certainly there. And increasingly, there was even some pretty important research that just came out in the past couple of days. I haven't heard a lot of press on it, but some of the first kind of sequencing of a relatively new to the scene disease in terms of our thinking around it, a thing called Piscine Rio virus, was recently sequenced and shown reasonably convincingly that it's likely something that just emerged here in the past 5 to 7 years. And it likely came from an initial Norwegian strain in terms of linking it back to where it originally came from. So, early days in terms of interpreting all that information, but there is a considerable body of work that highlights the potential for there to be concerns around disease in aquaculture and wild fish. When it comes to overspawning, many of you are probably familiar with the kind of cyclic dominant nature of different stocks of salmon in the Fraser River. So you end up with these 4-year cycles, right? So like the Adams Shuswap will be a 2012, 2006, 2010, 2014. dominant brood year. Different stocks or different collections of stocks will have different dominant years. And it's long been thought that the reason why you end up with this strong cyclic dominance is because of a thing called delayed density-dependent mortality, which sounds like kind of a mouthful, but essentially what it means is that in years when you have lots and lots of sockeye coming back to the spawning grounds, you end up with them leaving a freshwater environment that is less beneficial for the next couple of years than it otherwise could be. So for example, you might end up with a really big bumper year of Shuswap sockeye, and those juvenile sockeye will then pile their way into the lake for a year and eat up all the possible resources they can in that lake. So that those juvenile sockeye that are entering the lake the next year are actually entering a pretty resource poor lake, and so they tend to do not as well. And it's this kind of fulfilling prophecy where you end up maintaining this dominant line. Another way this could emerge is that you end up with rainbow trout that do very well. We were just talking about steelhead. I was talking with a gentleman. Can't quite see here because of the dark. Oh, there you are over here. We're just talking about we're talking about pink salmon, right? And the potential kind of pulse of nutrients that other fish can be for larger fish. So in this case, rainbow trout can really benefit from years when there's lots and lots of juvenile sockeye in a lake. And that means that in subsequent years, when there are fewer sockeye in there, you end up with that bolstered age class of rainbow trout that really hammer down those juvenile sockeye and maintain the cyclic dominance. And so, because as a result of conservation measures and a change in management that's actually been geared towards allowing more and more sockeye salmon onto the spawning grounds through time, we may ironically, the hypothesis was, may ironically be actually depressing their survival. And so we're allowing too many fish on the spawning grounds, and that could be contributing to the declines in their productivity and survival, culminating in the very poor returns and very off-prediction-based returns of sockeye in 2009, which prompted the Cohen Commission. And then the last hypothesis and idea occurred at a very different scale. So instead of thinking about things back in a nursery rig, now we're talking about pink salmon at this kind of ocean basin scale. Here's my crude approximation of the North Pacific. You've got the Kamchatka Peninsula over here, the Aleutian Chain in part here. This is Bristol Bay. Here we are, right somewhere around here, either Hawaii, Southeast Alaska. This is kind of a general schematic of what the ocean migration routes might be for sockeye that leave the Fraser River or southern BC. They migrate north along the continental shelf and then up into the Gulf of Alaska, where they'll migrate around like this for a number of years, growing, feeding, before they mature and come back to spawn. Well, while they're out there, they're not feeding and growing in isolation. They're doing this with many, many other salmon, including many other sockeye, as well as many other pink salmon. Pink salmon happen to be the most numerically abundant salmon species out there currently. And there are a lot that will come from this part of the range, and particularly from over here in the Eastern Pacific. And so in a given year, we may have over half of all the pinks in the entire North Pacific now coming from the eastern part of their range. Now, these guys also interact with an increasing number of chum salmon that come from these regions, and they're all feeding on many of the very same things in the ocean environment. And we know this because there's been some pretty detailed, back in the heyday of studying salmon, in some regards I feel like I'm a generation too late, there was a lot of resources put towards a high seas tagging program and high seas research where there's, across nations there was a lot of work invested in going out here, catching fish, tagging them, doing it over and over and over again. You get a real good idea of their distribution out in the open ocean, you get a really good idea of what they're eating. We're in a bit of, kind of reverse, kind of in a bit of decline in terms of, the role of science in informing a lot of these things in recent years. But nonetheless, what we know is that their distributions overlap, they're all feeding on the same things, and in those places where it's been well studied, primarily up here in Bristol Bay and interactions between sockeye salmon there and pink salmon over here, is that pink salmon are kind of like super salmon in their ability to exploit resources out in the open ocean earlier and switch to other prey more quickly than other species like sockeye salmon. And so pink salmon can reduce the growth and the survival and change the distribution of sockeye salmon at sea as a result of competing for the same resources. And because we're talking about an increasing number of fish overall that are competing for the same or changing amounts of food out in the open ocean, you would set up the situation where you can have increased competition for a limited amount of food out there. And when you overlay on this our propensity to produce fish through ocean ranching in particular, right? Hatcheries. So these are hatcheries. These are large-scale hatchery production programs that are geared towards making a lot of fish. 70 million adult chum, 60 million adult pinks in a given year, primarily from Southeast Alaska and from over here in Japan. You're adding another layer of potential stress and strain to the system. And so what we really wanted to do was ask for these 4 different hypotheses. If we take information on all the sockeye salmon that we know of and their populations from the Fraser, as well as the central coast of BC and just to the south, primarily just Lake Washington in this case, and we ask, given what we know about these different processes, if we put them all in some statistical models and ask, given the information we have, what does the weight of evidence tell us? Of these hypotheses, which ones have the most support, given the data that we have to base some kind of inference or interpretation on? And so this is an opportunity to, I came on board because my old PhD supervisor was one of the 2 folks that were leading the aquaculture section of the Cohen Commission. I got brought on board to do some of the analyses underpinning these kinds of ideas. And because of our understanding of the ecology of these systems, instead of just considering aquaculture in isolation, we wanted to think about aquaculture in relation to all these other possible factors that might be causing changes in the abundance of Fraser sockeye salmon. And this is what the picture ends up looking like. And I'm jumping through a lot of details and a lot of underlying complexity, but the basic picture that emerges is that as more and more pink salmon occur in the system, you end up with fewer and fewer or reduced survival of sockeye salmon, right? This manifests itself now in some recent research that we've done in reduced growth. So you can show that those Fraser River sockeye salmon that competed with large numbers of pink salmon also have reduced growth in a given year, as well as reduced survival. They also have delayed maturity, so sockeye tend to spend an extra year, a greater proportion of them spend an extra year in the ocean in those years when they compete with more pink salmon. And what we also found is that those sockeye populations that migrate past salmon farms have a kind of a double whammy. They do twice as bad, as those that don't migrate past salmon farms early in their life. So there's the potential for, and certainly the evidence supported this idea, that you end up with this kind of synergistic interaction where what happens early in life can be important for the outcomes of what happens later on in life. And because we were considering populations both from just the Fraser River as well as to the north and to the south, you end up with a system where you can kind of control in a given year for the effects of aquaculture, because only some of the populations you're looking at migrate past some farms versus others that don't, versus those broader scale kind of oceanographic consequences. And so this is kind of the picture that emerged from that analysis, which really highlighted that there's the potential for kind of coastal marine processes, in this case salmon aquaculture. And in this case, all we were able to work with is just the total number of farm fish that sockeye migrate past early in life. But that's the only kind of set of consistent information we have all the way back through time here in BC. We unfortunately don't have information on the occurrence of a whole suite of different diseases that some of which we're only starting to learn about now. But what happened halfway through this, and just before I spent time on the stand, the weeks beforehand, I was out, off the south end of T10, catching, more sockeye than I'd ever seen in my very limited lifetime here in BC, right? Sockeye fooled everyone and proved that fish are a lot smarter than BC experts, or experts much broader than that, for that matter, and really called into question the need for $20+ million being spent on the Cohen Commission. Well, it turned out that this provided a really exciting, albeit to some extent potentially challenging opportunity to say, given the work that we had done, and given this, what appeared to be this really anomalous event in 2010, what would our analyses have predicted would have occurred if we plugged in the numbers that we saw in 2010? So we plugged in how many pink salmon were out in the open ocean, how many farm fish sockeye migrated past, what the ocean conditions were like, and their interactions. What would our kind of models predict? And it turns out that our models actually did a reasonably good job at predicting a rebound in survival for those fish that returned in 2010, which were primarily sockeye that came from the 2006 brood years. We tend to think of them as the fish that came from a given generation of spawning. And the reason for that is because if you just plot out the number of pink salmon now, so this is broken apart from that earlier graph that was pink and sockeye and chum across the board. We all know pink salmon have a really strong odd year, even year cycle, right? This isn't ubiquitous across their entire range, right? So here in the southern part of BC, we have almost no fish that return in even years, pink salmon return in even years, and many fish that return in odd years. On the central coast, it's, there's still dominant lines, but it's a little more even. As you move further north, it switches. But as a general rule, across their entire range, particularly in recent years. So this was the number of pink salmon that interacted with sockeye salmon that returned in 2009, and this is the number that interacted with sockeye salmon that returned in 2010. You end up with literally about half as many pink salmon that they interacted with over the span of just 2 or 3 years. And so it's this pattern that allowed our models to predict this change. Now, it's not to say that our models are the be-all and end-all, and they are definitive proof that this was driving the system. That would be a naive kind of thing for me to claim up here, right? Because these are all based on correlations given the information that we have. But they provided kind of some of the most consistent and compelling evidence for an important contributing driver of pink salmon, and layered onto that some very clear evidence that those sockeye salmon that have to migrate past many salmon farms are doing that much worse than those that are otherwise interacting with the same number of pink salmon out in the open ocean, but aren't experiencing the same processes early on in life. Now you might ask, well, what possible mechanism might lead to this double whammy of migrating, being exposed to salmon farming and then being at a greater kind of losing end of interacting with pink salmon out in the open ocean? And we know from the ecological literature, there's lots and lots of examples where if your condition is impaired early in life, you can be more susceptible to all sorts of other things later in life. So your ability to potentially compete for resources in the open ocean may be influenced by your exposure to pathogens and disease early in life. That's a potential hypothesized mechanism that might underpin relationships like that. And so we're involved in a whole bunch of research that's trying to get more at the mechanistic understanding to really more thoroughly and rigorously evaluate whether or not that's really what is going on. And we're a ways off from that, but nonetheless, that's a possible mechanism that might explain it. Well, there's more to this story, because what we were really thinking about, and what I've just been talking about, are just these 7 clusters of sockeye populations throughout their range. So in this case, we're not going any further in the analyses I just described than the Central Coast, which really made up about 23 different individual stocks or populations that we consider. But a colleague and my postdoctoral supervisor also for the Cohen Commission did some work where he looked at patterns in the dynamics of sockeye salmon all the way across their range in the Eastern Pacific. So all the way from Western Alaska straight down through into Lake Washington here at number 1. And what this figure here is meant to illustrate is that blue means that the populations tend to do the same thing together. So when population 17 goes up, well, in this case, population 17 also goes up. These should all be very close to dark blue. But then the question is whether or not those that are close to each other in space tend to do the same thing. Or if they're all doing different things with each other, then you wouldn't end up with kind of clusters of blue, albeit you have to squint a little bit here, in terms of coherent dynamics in their system. And so what this means here is that, generally across this entire 54-year period, when sockeye from 2 and 3 here were doing well, then everybody in this cluster were doing well. And when they were doing poorly, everybody's doing poorly. But what Randall Peterman is the fellow that led this work, is that the coherency and the synchrony of these populations had changed through time. So they were becoming more and more consistent in their patterns. So if we're just focusing on the lower 10 here, this region right here below this bar, through time, they were becoming more and more coherent in their patterns, and that pattern was increasingly declining in survival. And so what this suggested is that there was a broad scale kind of driver that was at least contributing to coherent declines across that system. That's not to say that everybody was doing the exact same thing, because they weren't. And there was still variability across those systems, but it pointed to broad scale oceanographic processes that were the primary driver of these shared declines through time. And so what that meant is that it allowed us with an opportunity to ask, okay, given the relationship that I just described, they're more kind of localized to just our examination of information on the South Coast. We'd expect those same kinds of patterns to hold. If indeed pink salmon and competition ocean basin scale are contributing to things, we'd expect them to hold all the way across here. Now up here, we might not expect them to hold because there are real differences in the distribution of these fish in the open ocean as opposed to these fish with the limited information that we have. And when you look at what the picture looks like here, we'll just call this, the effect, quote unquote, of pink salmon on sockeye salmon in some sort of standardized unit. And what this means is that if you're on the negative side of here, as pink salmon go up, sockeye salmon survival goes down. And if you're on the positive side of things, as pink salmon go up, sockeye salmon survival goes up as well. And so it's the direction of the response across those populations. And what you can see is that in an analysis that considers 64 individual populations across all of these, those that are on this end, this is kind of the Yakutat Peninsula, southeast Alaska all the way down, all of them show a fairly coherent and consistent response to increasing numbers of pink salmon in the negative direction. Whereas those up here, you can kind of see if you draw a line up from zero, really all fall around kind of the no effect side of things. And so this suggests that the data match the kind of scale of the potential problem and the scale for the interactions to occur. Now this is very much an area of still kind of active research and thinking, but nonetheless it's consistent with the idea that there are really important consequences of ocean basin scale interactions and competition for a limited amount of resources. And so to wrap things up, what I would argue this work, though still in its early days, highlights is that if we want to ask the question, are there too many salmon in the ocean? Well, a bit tongue-in-cheek, but nonetheless one can say that there are, depending on who you ask. Right? And if you're a sockeye salmon in the southern part of their range, there likely are too many salmon in the North Pacific Ocean, and that's having consequences for your survival, your growth, your age of maturity, and your distribution, and things like ocean ranching and increasing the number of hatchery fish that are out there in the open ocean, and things like salmon aquaculture may, and I put this in italics and stress it, may further exacerbate that situation and what may further confound. So this really highlights the need for us, and this is something that we've struggled with over time studying salmon population dynamics, is you want to distill things to its simplest possible story. You want to think about individual factors in isolation. It is aquaculture, it is climate change, it is hatcheries, it is overfishing. And what this work really highlights is that in those situations where you can try and distill the individual consequences of those stressors as well as the sum total of them, it paints a bit more nuanced and complex picture. Where in this case, we really do have the suggestion that things that are happening close to home and things that are happening at a broad ocean basin scale are both contributing to things. And in this case, of the factors that we've considered, it really is the number of fish that you're interacting with at that broad scale that's an important contributing factor to declines in survival. And this is where I want to stress that this doesn't mean that in those years when there's lots of pink salmon, there's always going to be very few sockeye salmon, right? Because the world's not that simple. These kinds of things don't explain all the variation in the salmon data sets, but they are coherent signatures and patterns that emerge from trying to very rigorously examine this across many, many salmon populations. And in that sense, I think they really do add a lot of value and a lot of food for thought as we think about both how to manage human activities here within our kind of Canadian federal waters, as well as how we think about ocean basin scale processes, particularly in a changing marine environment when it comes to the climate, about how we make decisions as a kind of a global community about the consequences of what we might do all the way in Russia or in Alaska for those fish that might be in our part of the range. And that opens a very potentially uncomfortable but necessary set of questions and conversations that I think people have talked about for years, but this really highlights still needs to be part of the agenda when it comes to these. So with that, thank you very much for inviting me out here this evening and taking the time on a beautiful sunny evening to spend a half hour or so listening to what I have to say.